Hello, everybody. Welcome to week number 14 here. This is still going to be module number 14. Um, One last test we're going to show you is in section 12.2. This is the chi-square test of independence. Last week we looked at the chi-square goodness of fit test. Like last week, that test and this test are both non-parametric tests. Non-parametric tests relax the requirement that the parent population from whence the samples are chosen be normally distributed. The chi-square test of independence tests whether two categorical variables are independent versus dependent for the null and alternative hypotheses respectively. Just like with any hypothesis test, there's two ways to go about it: the critical value method, showing all 5 steps, and the p-value method, which utilizes the calculator. For this particular test, I'm primarily going to hold you responsible only for the p-value method. However, the example that I did post on Canvas does illustrate the critical value method with the 5 steps. So we're going to go through this one problem here using the critical value method, showing all 5 steps, and then I'll show you how to perform the test using your calculator. All right, so this is the problem. This is how it reads. It says employees of a multinational firm believe that an overseas assignment reduces the chances of promotion at the corporate headquarters. A random sample of 100 managers is selected, and the following 2x2 contingency or crosstabs table is produced. So here we see, ladies and gentlemen, that we have 2 categorical variables: promotional status versus overseas assignment status. And the promotional status has 2 possibilities: whether the employee was promoted or not promoted within the corporation rather. And the overseas categorical variable has 2 possibilities: where the employee had no overseas experience versus they did have some overseas experience. So does overseas experience affect or have any dependency upon whether or not the employee is promoted within the company? That's the issue we're going to investigate here. Notice of 100 managers that were randomly surveyed, 16 were promoted within the company and did not have any overseas assignment experience. 24 did have overseas assignment experience and were promoted. 22 were not promoted within the company and had an overseas assignment. 38 did not have were not promoted rather within the company and had overseas assignment experience. So these numbers 16, 24, 22, and 38 are called the observed frequencies collected in the field. Notice we have our column totals out here, our row totals rather, and our column totals down here. The hypotheses that we will be testing here, the null hypothesis for the chi-square test of independence is always going to test whether your 2 categorical variables are independent versus the alternative hypothesis, which says that those 2 variables are dependent upon each other. To say that they're dependent upon each other is to say that there's a relationship between the 2 categorical variables. We're going to investigate whether there is a relationship between promotional status and overseas assignment experience. So the null hypothesis in particular is going to say overseas assignment and promotion status are statistically independent of one another, whereas the alternative statement says overseas assignment and promotion status are statistically dependent. And notice we're going to test at 5% level of significance for this test. Our test statistic, ladies and gentlemen, is rather tedious to compute, but this is how we would do it if we used the critical value method to conduct this hypothesis test. The test statistic formula here is a double summation formula, and the double sigma or double summation notation is just indicating that we're going to add up all the entries of our table, including the entries in each row and in each column. And notice that we're going to always take the observed frequencies and subtract off what are called expected frequencies and divide the squared difference by the expected frequency. Now, these expected frequencies are going to be computed by using this formula above here. So we say the ijth expected frequency. I represents the row of the table, j represents the column of the table. So the row I, column j expected frequency is going to be found by taking the row I total, multiplying it by the column j total, and then dividing that product by the grand total. For instance, the 1, 1 expected frequency is the row 1, column 1 expected frequency. That is found by taking the row 1 total. If you look back at the table, the row 1 total is 40. Multiplying that by the column 1 total, which is 38. Dividing that product by 100, and we get 15.2. The 1, 2 expected frequency is found by taking the row 1 total, which is 40, multiplying it by the column 2 total, which is 62, dividing that product by the grand total, which is 100, and we get 24.8. The 2, 1 expected frequency, the row 2, column 1 expected frequency, is found by taking the row 2 total, which is 60, multiplying it by the column 1 total, which is 38, and dividing it by the grand total 100, 22.8. Finally, the 2, 2 expected frequency, the row 2, the column 2 expected frequency is found by taking the row 2 total, which is 60, multiplying it by the column 2 total, which is 62, dividing that product by the grand total of 100, and we get 37.2. So the idea behind this test, ladies and gentlemen, is to see what sort of difference we have between our observed frequencies and our expected frequencies. Now, these expected frequencies are under the assumption that the null hypothesis is true, that the two categorical variables of interest are independent of each other. And the idea behind this is the larger difference that exists between the observed and the expected frequencies, the larger our test statistic is going to be, which means that it's going to be more favorable that the test statistic is found in the upper tail rejection region of the continuous probability distribution known as the chi-square distribution, as this test statistic is distributed according to that probability distribution. So the idea is the greater the difference between the observed and the expected frequencies that exist, the stronger the evidence is to suggest that the null hypothesis is not true and the alternative hypothesis statement is true. So in computing our test statistic, now that we have our expected frequencies computed, and notice we have 4 expected frequencies because again we had a 2 by 2 contingency table, 2 rows by 2 columns, and 2 times 2 is equal to 4. That's why we have 4 expected frequencies, 1 for each cell of our table. To compute our test statistic, we take the 1, 1 observed frequency, which is 16. Look back in your table, the row 1, column 1 observed frequency. The row 1, column 1 observed frequency is 16, and the 1, 1 expected frequency, the row 1, column 1 expected frequency was computed to be 15.2. So all these numbers inside parentheses are the expected frequencies that we computed a minute ago. And we're going to take the difference between the observed and the expected frequency for each cell of this 2 by 2 contingency table. So the 1, 1 observed frequency minus the 1, 1 expected frequency, square that difference and divide that by the 1, 1 expected frequency. Plus, this is the 1, 2 observed frequency, the row 1, column 2 observed frequency, minus the row 1, column 2 expected frequency. Square that. Divide that by the row 1, column 2 expected frequency. Plus the row 2, column 1 observed frequency minus the row 2, column 1 expected frequency squared, divided by the row 2, column 1 expected frequency. plus finally the row 2 column 2 observed frequency minus the row 2 column 2 expected frequency squared divided by the row 2 column 2 expected frequency. When you dial this up on your calculator, you should get a test statistic which is about 0.113. Step 4 now is establishing a rejection acceptance region, and since our test statistic is shown by theoretical statistics to be distributed according to the chi-square distribution, which is a continuous positively skewed distribution, where the rejection region for this test is always going to be found in the upper tail of the chi-square distribution, which is separated from the rest of the curve, which is the do not reject null hypothesis region, by a critical chi-square value. Now this critical chi-square value is obtained by using a chi-square probability table and making use of the fact that the upper tail rejection region is the size of alpha, our level of significance, which we set back in step number 2, which is 0.05. So 5% of the area of this curve is found in the upper tail rejection region, and 95% of the area of the curve is found in the rest of the region, which is the acceptance or the do not reject null hypothesis region. Well, anyways, to find that critical chi-square value, we would have to use a chi-square table, as our calculator cannot crank that value out. It turns out to be 3.841 for the critical chi-square value. Well, ladies and gentlemen, now we're able to make a decision based on how our test statistic stacks up against the critical chi-square value. And this 0.113, our test statistic, which we computed up here, is less than 3.841. So our test statistic falls in the do not reject null hypothesis region of this probability distribution. And therefore, we are not going to reject the null hypothesis. And so, ladies and gentlemen, it appears that there is a strong chance that promotional status and overseas assignment experience status are independent of one another. In other words, sample evidence is not supporting the fact that both those variables are dependent upon each other. So it does appear that whether you're promoted within the company or not just does not depend in any way on whether or not you have any overseas experience. So again, we are not going to reject the null hypothesis for this particular test. So therefore, this is the critical value method for conducting the chi-square test of independence, showing all 5 steps. But my interest is conducting this test using the p-value method and having you use your calculator to ascertain the same decision that we gathered using this 5-step method. So now, ladies and gentlemen, I'm going to show you on your calculator how to do the chi-square test of independence. Hopefully my machine's working here. All right, so now we're going to go through this test again, but this time we're going to use our calculator. So therefore, this is going to be called the p-value method. All right, now to conduct the chi-square test of independence, we're going to first of all have to go into what is called our matrix mode on our calculator. A matrix, ladies and gentlemen, is nothing more than a table. A matrix consists of so many rows by so many columns. That's all a matrix is. It's basically a table. And notice for this particular table, we have 2 rows by 2 columns. It's a 2 by 2 table. So therefore, to conduct this test using our calculator, what we're going to do is, first of all, we're going to have to go into our matrix editing mode. And so, ladies and gentlemen, to do that, we're going to have to get into our matrix mode here. So on your calculator, there is a button that is entitled MATRX, Matrix. We're going to hit that button, Matrix button. And when we hit that button, we have 3 menus, Names, Math, and Edit menu. We're going to go over to the Edit menu. So hitting your right arrow key, move your cursor over to Edit. Oopsie. Hold on a second. My calculator. So we're going to hit Matrix. Oh, jeez. matrix. You know, I think I think my batteries are getting low here. Yeah, appears to be the deal. Hold on a second, let me see if I can do this here. So matrix. Well, anyways, first of all, what you would have to do here to go through this kind of like manually, is you would have to hit your matrix button. So MATRX. You'd have to go over to edit. Then with your cursor at the top of your screen, you would have to configure your matrix to be a 2. So type in 2, and then type in another 2. So 2 by 2 matrix. And then what you'll see pop up after you configure this as a 2 by 2 is you'll see like a little table pop up on your screen that has 2 rows and 2 columns. What you're going to type in now is the observed frequencies from our table. So the 1-1 observed frequency is 16. The 1-2 observed frequency is 24. The row 2 column 1 observed frequency is 22. The row 2 column 2 observed frequency is 38. So make sure you type in these numbers in the respective cells of this 2 by 2 table here. And once you do this, you need to then exit this matrix editing mode by hitting your second button, followed by mode. So second mode quits. So that's how you get out of this matrix editing mode. All right. Now, ladies and gentlemen, that you have your matrix entered into memory, you're ready to conduct the chi-square test of independence. To do so, what you do next is this. You now hit your Stat button, go over to Tests, and then you're going to scroll down till you run into the chi-square test function. Chi-square test. So you'll go down and grab the chi-square test. You'll then hit Enter. And then when you hit Enter, notice your observed frequencies will be in matrix A, because that's where we put our matrix, in matrix A. And your expected frequencies will be computed by your calculator behind the scenes when you conduct this test, and will be thrown into matrix B. And then I believe down here you have calculate. And then when we conduct the test, ladies and gentlemen, getting calculate, it's your p-value that is the most important value that we will be looking at. Now, I would suspect that when we do this test, our p-value, I don't know what the p-value is because my calculator has died on me, but the p-value will be large. It will be a large p-value, and because it's a large p-value, we will not be able to reject the null hypothesis. And so therefore it appears that promotional status versus overseas assignment status are independent of one another. So this is how you conduct the chi-square test of independence using your calculator. I will post, ladies and gentlemen, another video which will run you through the chi-square test of independence using your calculator. So stay tuned for that. But that's essentially it. So the chi-square test of independence is conducted first of all by populating a matrix with the observed frequencies, then going to Stat Test and selecting the chi-square test function, and just conducting a test and then reading off the p-value and making a decision whether you are or are not going to reject your null hypothesis. So I will be posting another video which will show you how to walk through this test using your TI-84 calculator. Okay, so all that remains, ladies and gentlemen, in the course is just doing the 12.2 MLP homework, the 12.1 and 12.2 MLP quiz, and then the MLP final exam, of which you will have two opportunities to do that final exam, and I will take the higher of the two scores. Keep in mind the quantitative project part 5 is also due by the end of the semester, which I believe is May 2nd. Double check the schedule. But that essentially is it. So if you have anything to turn in to me, make sure you do get in to me by May 2nd. I hope everything is all well. Stay safe and stay healthy, and stay home, and let's hopefully try to speed up the end of this virus here so we can get back to normal. If you ever have any questions, please do drop me a line, and I will get back with you soon. And I wish you all the best.